Hi, and welcome to this short tutorial. So this one is about molecular arrangement. So students will know the different molecular arrangements and motions account for the different physical properties of solids, liquids, and gases. So basically, how are the molecules arranged and why are solids, liquids, and gases different from each other? Okay, which diagram best describes the molecular arrangement for oxygen? Diagram 1? Well, in diagram 1, this is probably a solid. What is a solid? Diagram 2 is a gas, and it's a diatomic, which means there's two of the same atoms bonded together. This one's a gas too, and this one's a liquid. Well, oxygen at room temperature is a gas, okay, and it is diatomic. It's always found bond either to itself or to another atom. So the correct answer is diagram 2. Which of the diagrams best describes the molecular arrangement of a mineral? Well, what is a mineral? It's a solid. So we know then it has to be diagram 1 because diagram 1 is a solid. It's a fixed arrangement. What is the molecular arrangement like in a liquid such as rubbing alcohol, and why? The molecules are close together because of their strong intermolecular attraction and low kinetic energy. This is actually probably describing a solid, and rubbing alcohol is a liquid. The molecules are randomly packed together, but the molecules can slip and slide over each other. Sounds like a possibility because liquids do slip and slide over each other. The molecules are close together because the kinetic energy is dominant over the potential energy within the molecules. That's not the case. That one's not even true. The molecules are far apart because they're weak intermolecular attraction and high kinetic energy. Okay, this is describing a gas, and we know that rubbing alcohol is a liquid, so the correct answer is B. So in a liquid, the molecules are randomly packed together, but the molecules can slip and slide over each other. They can move. What is the molecular arrangement like in wood, and why? Well, what is wood? Wood is a solid, so we want them to be able to say that. The molecules are close together because of their strong intermolecular attraction. Okay, that's describing a solid, so A is possible. Let's double check though. The molecules are randomly packed together because the molecules can slip and slide over each other. That's describing a liquid, so that's wrong. The molecules are close together because the kinetic energy is dominant over the potential energy within the molecules. That's wrong. The molecules are far apart because of their small intermolecular attractions. That is a gas. So the correct answer is A, because that is what it's describing a solid. Okay, so make sure you know the difference between a liquid, solid, and a gas, guys, how they're arranged. Which of the following describes the differences between solids, liquids, and gases? Both have definite shape, but only solids have a definite volume. Well, they don't both have definite shape because I can pour a liquid into anything and it takes the shape of the container. Both have definite volume, but only liquids have definite shape. Again, this one's saying liquids have a definite shape, which is false. Solids have a definite volume and shape, but liquids only have a definite volume. Sounds close because solids do have a definite shape. Liquids do have a definite volume. I can only pour 20 milliliters. If I have a 20 milliliter container, I can only pour 20 milliliters into it without it overflowing. Okay, liquids have a definite volume and shape. Make sure you read carefully. It's saying it has definite shape, and that's wrong. So the correct answer is C. Solids have a definite volume and shape, but liquids only have a definite volume. Which of the following best describes the differences between liquids and gases? Both have definite volume, but only liquids have a definite shape. Well, we've already proved that liquids don't have a definite shape. Both have definite shape. Okay, again, that one's wrong because liquids don't have a definite shape, neither does a gas. Gases have a definite volume, and liquids do not have either. Liquids does have a definite volume and gases do not. Liquids have a definite volume and gases do not have either. Sometimes it's easy when you take a test just to look at each answer and prove that one true or false. And when you do that, you're guaranteed that your answer is correct because you've used logic to get there. A student wants to test a mystery substance to find out what state of matter it is. Which characteristics can be used to determine its state? Okay. Can we use A, volume, density, compressibility, and flow? Well, this is a good choice because compressibility would be like gases are very easy to compress, liquids can be compressed, not quite as easy, and solids can't be compressed, so it would help you differentiate. Okay? Volume, density, and mass? Mass, not so much, because you know what? I can have a liquid that's the same mass as a solid. And flow means how does it pour. Shape, flow, and temperature? Not really going to tell us much, is it? Because the liquid can assume the shape of the container it's in. And temperature really can't. Solids can be one temperature and liquids could be the same temperature. It doesn't really differentiate. That's also why D is wrong. So the correct answer is volume, density, compressibility, and flow. Flow is like how does it pour or move. Okay, a student runs a test on a mystery substance that found it has a definite volume, which means it's either so it can't be a gas, not a gas. Okay. Flows easily. Not a solid. So we know it's not a gas or a solid, so we know it's got to be a liquid. Okay. How did I know that? Because it has a definite volume, it cannot be a gas. So it's either a liquid or a solid. And it flows easily, which means it can't be a solid. Okay, it is a solid. We already eliminated it. It is a liquid because it has a definite volume and a high density. Possible, but you know what? Let's see if there's a better answer. It is a solid. We know it's not. It is a liquid because it has a definite volume and it flows easily. How did we determine that it was a liquid? We knew its flow and we knew its volume. That's what we used to determine it. Okay, guys? And the reason I would go with that being more the correct answer than the other one is because really density can vary. We could have a liquid at high density and a solid at high density. So the best choice here is a liquid because it has a definite volume and it flows easily. Okay? Which of the following correctly describes the motion of particles in a solid? Well, for those of you who don't know this, they do move, so A is wrong. They do not move rapidly. They do not flow easily because this was a liquid, more like a liquid. They vibrate in a set pattern. That's the motion of molecules or particles in a solid. Which of the following correctly describes the motion of particles in a gas? Well, they do move, okay? They move very rapidly in random patterns because gas, I always equate gas as like to the mosh pits. It's like random motion. They don't vibrate in a set pattern. This one would be a liquid. This would be a gas, not a solid, sorry guys. So that leaves this one as the correct answer. All particles in a solid, liquid, or gas move. Okay, that's why I know A is wrong. So which of the following correctly describes the motion of particles in a gas? They move rapidly around in random patterns. What is happening in the particles of a solid as it changes phases into a liquid? Okay, well, for the kinetic energy increases as you go from a solid to a liquid. So that means I'm having more particle movement. Okay, so they don't slow down. Okay, they don't slow down. They're going to be speeding up. So anyone that says they slow down and spread apart because energy is being added, nope. If you're adding energy, you're going to have more movement. They don't slow down. Okay, they speed up and spread apart. It's closer. They speed up and become closer because energy is being removed. Actually, that's wrong because remember we said they flow easily. They're not coming closer together, nor is energy being removed. That's just wrong. Energy is being added. They speed up and spread apart because energy is being added. Okay, so when I go from a solid to a liquid, I am adding energy, and my particles start speeding up and spreading apart. What is happening to the particles of a gas as it changes phase into a liquid? Okay, guys. So kinetic energy is increasing. So here's solid, liquid, gas. So what we're trying to say here, Because we're going backwards. We're going from a gas to a liquid. We should have a decrease in kinetic energy. Okay? So they are going to slow down. So C and D are wrong because they're saying they're speeding up. Okay? A, let's read A because it's correct in saying that they slow down because that's what we said. The particles are going to slow down. They slow down and spread apart because energy is being added. Do you think if kinetic energy is decreasing, that energy is being added, or is energy being removed? It's being removed, guys. So A is wrong because it's saying that they're doing that because it's being added. And the correct answer is they slow down and become closer together because energy is being removed. So when I go from a gas to a liquid, the particles slow down and become closer together because energy is being removed. Which of the following describes a state of matter that has a fixed molecular arrangement and the particles are close together? Well, what do you guys think? First off, you should know that if it has a fixed molecular arrangement, it's a solid. Okay. A substance that has strong attraction between particles and low kinetic energy. That actually is really close to the description of a solid. A solid has low kinetic energy. Think about, remember that arrow I drew where I said that kinetic energy increases as I go from a solid to a liquid. So a liquid has more kinetic energy than a solid, and a gas has more kinetic energy than a liquid. So this one says it would have a high kinetic energy, and that would be wrong. This one says a high kinetic energy. And guess what? Solids are very attracted to each other. So D is wrong because it says a little attraction. They have a strong attraction between particles, and they have a low kinetic energy. So which of the following describes the state of matter that has a fixed molecular arrangement and particles that are close together? Number one, we're talking about a solid, and that is a substance that has a strong attraction between particles and a low kinetic energy. Which of the following describes the state of matter that has random molecular arrangement and particles that are far apart? Okay, first off, what is it? It's a gas. Okay, so we want something that's going to describe a gas. A substance that takes the shape of its container is not easily compressed. Well, that's describing a liquid. Okay, a substance that has a definite shape and is easily compressed. That might be a solid because some solids can be easily compressed, but it's not a gas. A substance that takes the shape of its container and is easily compressed. That does describe a gas. Okay, so we're going to double check to make sure that is the right answer because we know that A described a liquid. B potentially could be describing a solid, maybe Jell-O, semi-solid. And A sounds like it, or C sounds like a gas, but we're just going to double check to make sure we're reading the answer right and read D's. A substance that has a definite shape and is not easily compressed. Oh, that's definitely a solid. So that can't be a gas. So the correct answer is C. Okay. Which of the following describes a state of matter that has a random molecular arrangement and particles that are far apart? That is a gas, and its correct answer is a substance that takes the shape of its container and is easily compressed. According to the kinetic molecular theory of particles in ideal gases, they A, behave like tiny discrete particles in a state of constant random motion. That sounds like the kinetic molecular theory. Let's keep moving. Behave like hard spherical objects in a state of constant, nope, because remember gases are random. Lose some energy when they collide with each other or with the walls, nope. Have strong force of attraction, no. Gases don't have strong force of attraction. So the correct answer is behave like tiny discrete particles in a state of constant random motion. Which of the following is not part of the kinetic molecular theory of gases? Attractive and repulsive forces between gas molecules are negligible. This is part of the theory. So that can't be it. Gases consist of molecules in continuous random motion. That's true. We should just know that about gases. It doesn't even matter if it applies to this theory or not. Collisions between gas molecules do not result in loss of energy, and that's true. Matter is conserved in ordinary chemical reactions. Well, that is the law of conservation of matter. It is not part of the kinetic molecular theory. So that's the answer, because which of the following is not part of the kinetic molecular theory? Well, it is that matter is conserved in ordinary chemical reactions. Bye, guys. I hope this tutorial helped you out. Have a good one.